this episode, how to convert degrees to radians and vice versa, coming up back into action. Hey guys, today I will show you how to convert degrees into radians and vice versa. Before we get started, first of all, how to distinguish, how to differentiate degrees and radians? Well, it's just two different ways of measuring an angle. It's kind of two different units that your angle can be given. Well, let's say you are given 220 degrees. And the way you say that your angle is given in degrees, you're given a number that has this little kind of circle up in the corner. Whereas for radians, either you are given just a number, it could be just 14, and it's nothing, and sometimes it's written RAD, which is abbreviation and it stands for radians, or more likely you are given something like 9 pi over 2, also radians, and your number containing pi. So it's something like 9 pi over 2, 3 pi over 2, 6 pi or whatever. So when you see this pi appears your number, so you would definitely say that you are given in radians. You are given radians. In radians. Alright. Now, the fact that you should know it's the full circle, entire circle, the full revolution has 360 degrees, which is basically the same thing in radians. It's equivalent, it's equal to 2 pi. So it's entire full circle. So if you are given a circle, so the entire circle has, the full revolution has 360 degrees, or in other words, it's the same thing as 2 pi. Now, typically what we can do is just divide two sides by 2 in order to simplify this kind of equation. And you would be left with something, since 2 goes into 36 18 times. So 180 degrees equal, and these two cancel each other out, it goes away, drops out, equals just pi. So you can take this equality as a conversion equation for all these conversion problems. So 180 degrees, it's precisely the same thing as a pi. How to convert degrees into radians? So let's say you are given x degrees and you want to convert it into radians. Let's say theta radians. So all you need to do is just multiply your degrees by pi over 100. This is kind of your conversion factor. The way back, if you are given a radians now and you want to get the degrees, so all you do is just multiply your radians by the flipped version of this factor. So you need to multiply it by 180 degrees over pi. Now, let's put it to the test. Let's say you have been given 30 degrees and you need to convert 30 degrees into radians. Now, the way you would do is just write this 30 degrees. And you need to multiply, since we're going this direction, so we're going to convert it into radians. So we're going to multiply it by pi over 180 degrees. So times pi over 180 degrees. And there is a kind of a ninja trick to remember, mnemonic trick to remember which factor to choose, which factor to pick, since it might be a little bit confusing, especially when you start off. So the way you would remember, since you want to get the radians, so you want the degrees to be cancelled. So since you are given a degree, so you want to put this on the bottom of your fraction in order that your degrees cancel. So basically you want to them cancel. So this degree symbol is cancelled and you would be left with radians. That's what we want. Now, all you need to do is just simplify this fraction down. So make sure you get it in the simplest form possible or conceivable. So the great news that this 0 would cancel each other out. And also, since 3 fits into 18 6 times, and you still have this pi on top of your fraction, you would be left with pi over 6. That's your radian measure for that 30 degrees. So in other words, that 30 degrees, it's the same thing as pi over 6. And if you like, technically that's radians, and you could write radians, RAD, as a unit, but mostly it's implied as soon as you have pi in your number, it's implied, it's understood to be radians. So it's kind of overkill to my personal opinion. But if you are asked, or if you like, you could just write these radians. That basically indicates that you have radians. Or again, so it's, for me it would be a little bit overkill, but completely up to you. Anyway, that's your answer for that conversion problem. Now, let's say you have been given something like this, 10 degrees, and you need to convert it into radians. Likewise, you always start with this actual number that appears in your problem. So in this case, it's 10 degrees. Again, I'm going to this direction, so I want to get my radians. So you multiply it by, so again, you want to put 100 degrees on bottom of your fraction in order that your degree symbol will cancel and we could get rid of this. And also your pi goes on top. Now all you need to do is just make sure you get it in the simplest form possible or conceivable. So great news again, so zeros goes away and basically we are done. So pi still remains on top of your fraction and you have 18 on bottom. So any more simplifying could be done at this point, and that's your final answer. That's your radian measure for that 10 degrees. As I mentioned before, if you like, no harm, you could add this RID, which stands for radians, but from that answer, it's obvious that you are that you are left with radians. Alright, let's convert radians into degrees. Say convert 15 pi radians into degrees. Now, you always start with this 15 pi, the actual number that you are given. So 15 pi. Now you are going to multiply it, so keep in mind we are going the opposite direction. So all you need to do is just use this inverse version of this conversion factor. So, and again, you could memorize this, or you could use this mnemonic trick, this mnemonic device. So since we are given pi is in your number, so you want to put this pi on bottom of your fraction in order it will cancel each other out, and you would be left with degrees, what we want. And 180 degrees goes on top of your fraction. As I mentioned before, this pi drops out, it goes away, disappeared, and you would be left with 15 times 180 degrees. And all you need to do, if you're allowed to use calculator, you would basically punch it, plug it into your calculator and work out and get this number, or you could do it by hand, obviously, and you would be left with 2,700, kind of huge number, degrees. So don't forget to write this little circle up in the corner that indicates that you are left with degrees. So that's your degree measure for that angle. Now, suppose you have been given 4 radians and you need to convert it into degrees. And notice there is no pi in your radians. So it's just a naked, if you will, number. So it's just 4. Same idea. So you want to multiply this 4 by that conversion factor, because still, even if you don't have that pi in your number, so you still want to get this direction, so from radians to angle to degrees. So, and your 180 degrees goes on top. That's little bit different from before, since there is no pi in your number. But all you do, you could simply, you plug it into your calculator, and whatever decimal you get, so it's gonna be your degree number for that 4 radians. With this being said, I hope it has been helpful to you. Huge thanks for watching, and Jenny Brain. I know everyone hates maths, but if you like my video, please hit this like, share with your friends, leave the comments down below, and be sure to subscribe, to smash that subscribe button if you haven't, so you will not miss out my new videos. In this episode, how to convert degrees to radians and vice versa. Degrees and radians. Did I say radians? No, I didn't. Did I? Forgot. 15 pi.